Hello everyone, so in this video let us talk about the first problem from the latest LEETCODE weekly contest 388. The problem name is apple distribution in boxes. So as you can see, you are given an array apples of size n and an array capacity of size m, as you can see here. Now there are n packs where the ith pack contain apple I number of apples. So as you can see, there are different number of packs and each packs contain this number of apples inside them. Now there are m boxes as well. So you can assume that these are different apples and these are different boxes. And every box has the capacity given to you in the ith position. Return the minimum number of boxes that you need to select to redistribute. As you can see here, you can also redistribute these n packs of apples into boxes. So you have to take these apples and redistribute inside the boxes, and you just have to require the minimum number of boxes. So as you can see here, that I just want to take these apples and put it inside the inside these, you can say, containers or like say boxes, and you want to choose the minimum number possible. So as you can see that you have to choose the minimum number of possible boxes. So it can be done using greedy method, because you can greedily choose the one boxes which are the maximum in size. So if you take this hypothesis and use this and take these examples, as you can see here as well, if you take these apples, the total is, as you can see, six apples you have. So you can first take the very maximum box, that is 5. Then you can take the next maximum, that is 4. And in both of these boxes, you can store 6 apples, so that is fine. So the number of boxes you will require is 2. So in simple terms, you just have to take out the maximum, like one after the another maximum boxes, and keep on storing these apples inside them. And the end, how many number of boxes you'll use, you just have to do that. As you can see also, the capacity is sufficient. You don't have to put the complete bag here. So as you can see here, that the first bag is 5, so you can put it in this, like in this box, that is 7. The next is again 5. So there is no, as you can see, box of size 5 which can hold the complete bag. So you can redistribute. You can put 5 here and 1 here. Okay, so like you can do it like this as well. So you can redistribute as well. So you just have to ensure that how many boxes you have to do. So you can just find the total number of apples that you have. That is the total of apples. And then from that apples, you just have to sort this array and keep on choosing the very maximum and put the apples. If you still have any apples, you can put it inside the boxes until like all the apples are like put inside the boxes. That's the complete logic for this complete problem. Let's move on to the code part now. Nothing much complicated here itself. So what we have done is that we have sorted the complete capacity boxes from the very maximum to the very least capacity. So I've used R begin and R end. Then we have the complete sum of all the apples that we have find out using the accumulate, as you can see, function provided by C++ library STL. And then what we have done is that we have to take every box possible. Let's say from every box, the maximum to the smallest capacity. You will take the boxes and then check that whether you have some apples that you can store inside this box. So if you have some apples, then you will take all the apples you can, put it inside the box, and because you have stored that much of apples inside the box, your number of apples is reduced by this capacity, and because you have used this box, you will increase your box by 1. So in the end, what you're trying to do here is that you will keep on taking the number of apples you have and keep it storing inside some box of capacity this, which is maximum possible, and you're going from maximum to the smallest. Now if your all the apples are exhausted, you have like included all the apples inside the, you can say, boxes, then this will become like 0, because you have used all the apples. So this will become 0 and it will not go inside this if loop, like if condition, and thus you will only take the number of boxes until you have some apples left to be stored inside some boxes, and then this boxes count will increase, and the end you will just print out how many boxes you have used. That's a complete logic. You are using the sort function that will be O of log n in like n into n log n. Okay, this is just a for loop, so which is O of n. So the overall time complexity is like determined by this sort function only. Though the constraints are pretty much small, as you can see here as well. Constraints are pretty much small, but still, if you have to find out the complete time complexity, it is O of n log n. That's a complete logic and code part for this particular problem. If you still have any doubts, you can mention in the comment box for this particular video. I will see you in the next one. Till then, keep coding and bye.